Hey guys, Mr. B here, and in this video we're going to be doing the Newton's first and second laws lab. So let's get started. Alright, so for the first part of the lab here, we have a stack of 4 washers. We're going to take one washer and we're going to flick it at the bottom of the stack, and we're going to try and see what happens and make any observations about Newton's first law of motion. So I can't promise I'm going to do it on the first try, but here we go. Let's give it a shot. Alright, so write down what you saw, and we're going to move on to flicking 2 washers at the stack. Alright, so we now have 2 washers. We're going to flick at the stack of 4. I want you to watch what happens and write down on your sheet any observations that you make. Alright, so now we have 4 washers. We're going to flick at the stack of 4. Again, I want you to watch and make note of anything that occurs on your sheet. Alright, we're here for part B now. What I've done is I've taken a little note card and I've cut a circle out, taken some tape and taped a piece of string to the back. What we're going to do is we're going to put this on top of a clothespin like this. We're then going to take a penny and put it on top. Try to make sure it doesn't fall over. And now we're going to try to see if we can pull out this little note card from underneath the penny while keeping it in place. Okay, so this is kind of like the magician's trick with the tablecloth. So we're going to try to do this. I can't tell you I'm going to do it in the first try, but here we go. First try, no big deal, guys. You know, I'm just a pro at this. So, all right, cool. So write down any observations that you made, and you know, if you're watching this as a video at home, maybe try doing this on your own. There's a second part here we're going to go over where you can do this without having to need a clothespin. All right, so now for the next part of part B, we're going to take that little card again, though this time there's no string attached. We're going to put our penny again on top, and we're going to see if we can flick this card out from underneath without causing the penny to go anywhere. Again, I can't promise I will do this on the first try, but here we go. Ooh. All right, let's try it again. Nope. All right, third time's charm. Here we go. All right, guys, there we go. You saw it yourselves. 3 tries, we got it. All right, again, if you had a clothespin, you can try this at home. Otherwise, you're probably doing this in class. So let's move on to the next part. All right, we are back here with the third part of part B. So now we're going to take our piece of paper with our string attached to it. We're going to put it on top of our finger. I'm using my thumb here because it's a little bit more difficult for me to use other fingers when I'm trying to manage a camera. At the same time, we got our paper up there. Take our penny. I'm going to put it on top of my finger like so. And now we're going to try to pull this out from underneath, again, while keeping the penny in place. So, again, can't promise I will do this in the first try. We're going to do the best we can. Ready? Here we go. Bam! Man, I'm a magician. All right, guys, you try this one on your own. And, yeah, tell me if you can do it in the first try. All right, so we did the third part here with string on the paper. Now we're going to try with no string and see if we can flick this card out from underneath the penny as it sits on my thumb. Now this one I think is going to be a little bit more tricky, but we'll do the best we can. So I'm going to make sure my penny's balanced properly, and here we go. Again, can't make any promises I'll do in the first try, but I'll try my best. 1, 2, 3. Oh, that was terrible. Try again. All right, attempt number 2. And here we go. Oh, closer. Nope. Oh, a lot closer. All right, attempt number 5. Oh, there we go. We did it. Only took 5 tries. All right, guys, you've seen me do it. Can you do it? That's the question. We're going to move on to the second part of this lab, which is Newton's second law. So finish answering the questions for this first part, and then we're going to move on to the second part. Alright guys, so welcome to the second part of the lab. This is now Newton's second law of motion. What we've got is we've got a little ramp here set up. And what we're going to do is we're going to take a Hot Wheels car and we're going to roll it down this ramp. And we are going to see how far it goes. And as we do that, we are also going to be changing up the weight of this car. So we're going to add some washers to it. Okay, so what I've done is I've taken some washers here. And we can see that I've taken some tape. And I've put them around the washers like this. So we're going to take these washers, we're going to put them on top of our car, and then we're going to make the car heavier and see if that affects how far it goes, again, when we put it down our ramp over here. So let's get going. Alright, so this is going to be trial number 1. We have 0 washers on the car. We're going to make sure that we always put it here at this tape mark, and we're going to let it go and see how far it goes. Here we go for trial number 1. There goes our car. Let's take a look and see what our measurement is at. So the car is about there. And let's see, we have 1, 2, let's say we will have it at about 2.86 meters. Okay, so about 2.86 meters, I think is probably a pretty good number. Okay, so we're going to write that down. All right, here we go for trial number 2, again with 0 washers. Let the car go. All right, there we go. Not bad, not bad. Let's again take a look and see. So I think this time maybe about 2.80 meters, a little bit shorter than the last one. So we're going to write that down for trial number 2, 2.80 meters. All right, final trial here. 0 washers, trial number 3. Here we go. Let the car go. All right, let's take a look here and see. I would say this time it is about 2.86 meters like it was for trial number 1. So write that down for trial number 3, 2.86 meters. Alright, so now what we're going to do is we're going to take our 5 washers and I'm going to take a little loop of tape and stick it on the bottom like this, and we're going to stick this right on top of our car. So now we've added some more mass to the car, and also we're going to do it this way so that way the tape doesn't interfere with the wheels and cause this car to not go as far because there's too much friction. So let's get going for trials 1, 2, and 3 with now 5 washers on our car. Alright, here we go. Trial number 1 with 5 washers on the car. Let's let it go. Alright, let's take a look and see what we have. So this time, I would say it went a little bit less far. I'd say about 2.78 meters for this trial. So 2.78 meters for the first trial with 5 washers. Alright, here's now trial number 2 with 5 washers on the car. Here we go, let's let it go. Alright, so let's see what we have. So this time, I would say about 2.72 meters, so a little bit shorter than the first one. So 2.72 meters for trial number 2 with 5 washers. Alright, last one, we have trial number 3 with 5 washers on the car. Here we go, let's let it go. Alright, this time, I would say the car is about 2.72 meters, so the same as trial number 2. So for trial number 3 with 5 washers, again, we have 2.72 meters. Alright, so now for the final trial, or the final part of the lab here, we now have added another 5 washers on our car, so we have a total of 10. Again, I just put a little loop of tape underneath here and stuck them together. So now we're going to try out with 10 washers and see how that affects how far our car goes. Alright, here's trial number 1. We have 10 washers on our car. Let's let it go and see where it goes. Wow, this actually went pretty far this time. So, let's take a look here now with 10 washers on our car. It looks like our car went about 3.26 meters, so that's farther than any trial so far. So for trial number 1 with 10 washers, we have 3.26 meters. Alright, here's trial number 2 with 10 washers. Again, let's set the car up on the tape mark and let her go. Alright, so let's take a look and see. So I would say this time it didn't quite go as far, but it definitely went further than with 5. So I'd say we have about 2.96 meters for this trial. So Trial number 2, for 10 washers, we have 2.96 meters. All right, we're here for the last trial with 10 washers. Trial number 3, set our car up. Here we go. All right, so for this one, it looks like our car went about 2.83 meters, so not quite as far. So 2.83 meters for trial number 3 with 10 washers. Hey guys, so we are now done with the physical portion of the lab and running all the cars and all that stuff. Now we're going to answer some questions. So the first thing is, I want you to calculate the average distance that your car traveled with 0 washers, 5 washers, and 10 washers. Okay, so you should have numbers for your 3 trials. Again, find the average distance that each one traveled, and then from there, we're going to take a look at the post-lab questions. All right, so for the data that I got, my average distance for 0 washers was 2.84 meters, for 5 washers was 2.74 meters, and for 10 washers was 3.01 meters. All right, so let's take a look then at our post-lab questions. The first one here for Newton's second law says, how does increasing mass or adding more washers affect the force of objects in motion, which is in this case the distance the vehicle rolls? Explain your answer using data from the chart. So I'd like you to pause the video and try answering that question based on the results you either saw in class or based on the results that you saw in this video. And then you're going to hit resume and see how I answered it. All right, so looking at the data that I got, our 10 washers definitely went further than 5 and 0. So it looks like by adding more washers to our car, it was increasing the force or increasing the distance that the car was traveling. We did have a little bit of a discrepancy because for the 5 washers, that actually traveled less far on average than the 0 washers did. But, you know, it could be that maybe the car was turning. That definitely happened on some of the trials. The car kind of turned. It didn't go fully straight, so maybe we lost some distance because it turned a little bit. But, you know, it was definitely very clear that 10 washers did seem to go further than 5 washers and 0 washers. Okay, so that's what I put down for that question. All right, taking a look at question number 2. What would happen if you added 15 washers to the car? Predict how far the car would roll. So again, I'd like you to pause the video, answer this question on your own, then hit resume and see what I have. So it looks like if we were to add 15 washers to the car, my prediction would be that the car would travel further than it did with 0, 5, and 10 washers. As to how far would the car roll, well, we added 5 washers and it didn't do a whole lot, but then adding another 5 and having 10 washers, it looks like we are getting maybe another 20 centimeters. So I would just say maybe we gain another 10 centimeters, like half of that. So my prediction would be that maybe we could get the car to roll 3.10 meters on average rather than 3.01 meters on average if we had 15 washers. But again, that's just my prediction. All right, the last question here we have is, explain the results of your experiment in terms of Newton's second law. So pause the video, answer this question on your own, and then I'll show you what I have. All right, so Newton's second law of motion basically says that acceleration is equal to force divided by mass. Or we can also rewrite it as the force of an object is equal to the mass of that object multiplied by its acceleration. Now in this case, the main way we want to use it is the acceleration equals force divided by mass. So in this lab, we increase the mass of our car. By increasing mass, that also is increasing the weight of the car, because weight is a measure of force. It's how much gravity is pulling the car down to the ground. The more mass it has, the more weight it has. So by increasing force and increasing mass, we should ultimately then see an increase in acceleration, which kind of relates to then distance and how far that the car goes. So in this experiment in particular, I think increasing the force and increasing the mass of the car increase its acceleration, causing it to travel further. And that's pretty much what we saw in our results. Again, the 5 washers maybe didn't kind of work out the way we wanted, but the 10 washers definitely did. So, all right, guys, that is it for this lab. Thanks for sticking with me. Hopefully you learned something about Newton's first and second laws of motion. But if you have any other questions, as always, feel free to email me, reach out, talk to me in class. Just make sure that you get your questions answered. All right, guys, that's it for this lab. See you in the next one.